Let's continue off where we left off in the previous session. I said that I would look into C++ dictionaries. I started off with by asking Perplexity, is it a mutable dictionary? It is, but I was surprised that it's actually based on a red-black tree. In F sharp, F-sharp's maps are also, I think, based on a similar data structure. It's not a red-black tree, but it's an ABL tree. And those maps are immutable, but in C++ it seems they're mutable. And this unordered map is what would be a dictionary in Python or .NET. Here I ask how it does hashing, and yeah, I clicked on this link. And okay, I didn't even read this question, but this answer is pretty good. And they gave me an example how to use okay, this is the equality operator. It needs equality and it needs a hashing. So over here they do it by overloading this to the data structure. And now with that in place, it's possible to instantiate the dictionary. I scrolled down a little bit and found this. And this is much easier for us to do in something like Spiral, because we could turn the hashing function into a function pointer. We could also turn the equality function into a function pointer, then just pass it into the unordered map during its construction. And these types, since we won't be using the declared type of this lambda, which can be pretty much it's kind of like I think a specialized type to that closure. We don't want to use that because we want to be able to pass a dictionary into functions and so on as a reference. So let's try it out. Like we can try it out in Spiral right now. All right, let's see whether it. Right now it's still at 2.17.2. Let's upgrade it. Close this. Let's open the ML library. And now we'll be able to work in the latest pre-release version of Spiral. I have no idea why Visual Studio Code isn't upgrading automatically to the latest pre-release version. Actually, let's ask that Perplexity. Why is VS Code not upgrading to the latest version of the latest version of an extension? I guess it's kind of like a limitation of the editor. It's not a big deal. We're going to release an actual version soon. So okay, let's close this. Let's compile something like. Okay, let's make that main 0i32. Let's bring the file. And this just gives us a new file to start with. Now let's try. Let's start with this. So we need the hash. Wait, what exactly do we need to include? Yeah, we definitely need the global unordered map. Yeah, let's move to a sitting position. I have been doing exercises for a few days now. So, but I'm going to start them again tomorrow. I kind of got a treatment for a Pacific cat in my right shoulder, so I've been purposely holding off. Okay, so we have the unordered map. Actually, I meant to just put it in here. Global. Okay, so first thing is first, I want to see whether I can do this using h stud hash. And what I should be, I just want to see whether this compiles or whether I also need to include something like stud hash. It has worked. I guess including another map automatically includes the hash. So actually, I'm not really sure whether I need. Yeah, we don't actually need the stud hash. We have our own hashing function in the core library. What we do need is the equality and the hash functions. Okay, so let's make a data type. E. I'm going to make it 182 through 364, something like that. Value SDF. Now, how do we define the dictionary? Another map. Um, now, put under another map. Value. Okay, value. And this thing here, we're going to make it something like a function pointer of what? Wait, is it supposed to return a boolean or something like an integer? Okay, the hash is supposed to return an integer, I think. Let me just copy paste all this. Sick. So, oh my god, what is it doing to me? Okay, so let's just post this here, comment it out. Now we'll have it as a reference. I just want to scroll up a bit so I can see what exactly is the return type. Operator. So it's size t. Okay. The result of the quality operator is this boolean. And over here it's size t. Okay, not bad. So I guess in size t would be what? I think a 64-bit integer in C++, most likely. But whatever, we can also just return a regular integer. It's not going to complain. So, okay. So let's make this fptr. I mean, how do function pointers even work? I mean, in Spiral, not in C++. Okay, we have this. So it's like that. We also have heap allocated closures. And over here, to fptr. Okay, so it's like that. It doesn't have two arguments. It just has a function within it. And I've added this feature specifically for interop purposes with the C++ libraries. It also we literally now have three different functions in the C++ backend. The regular closures are like these anonymous lambdas. They cannot get compiled to a custom functor. Sorry, I meant these anonymous lambdas. They cannot get compiled to a custom unique functor. They cannot be passed through join points. Also, we have function pointers, as you can see here, and on top of that, we have heap allocated closures that can take in free variables. Function pointers cannot have free variables. Okay, so let's do key, and it's what? So this is a hashing function. Let's make it int. What's the problem here? Of course. So when we actually construct the type, we do it like this, I guess. Okay, that's one function pointer. Now we need the quality, and that's key boolean. Bool. So we have the type for the unordered map. Okay, so we have the key and the value. We're going to have to construct the unordered map, or rather, let's call it a dictionary. Dict. You don't have to keep calling it unordered map. Just call it a dictionary. I have no idea why C++ has to invent new terms for everything. Dict, and this is what? Uh, 32, bool, 64, and this is a string. Obviously, this isn't that. So what we have to do is use a macro, and then what? Let's start it off like this. Create dict. Okay, key value. Let me just put it here. For our key value. Key value. Actually, no. We just need the. Yeah, we don't even fucking need the key and the value. It's not like we're adding to the dictionary. What was I thinking? No, we just take this. And what? We have a variable here, and we need a constructor, and that's like, let's call it 8. Okay, let's just put in capacity. And capacity. And what do we have here? We need the 2fptr. 2fptr. And we need to pass in the hash function. That hash function should be in the core library somewhere. I mean, it should be like right here. Hash. Really? It isn't here? Oh, what the fuck? Yeah, I mean, it's definitely here, even if it's not in the top-down segment. Okay, so here is the comparator. Here is equality. Oh my god, I really don't have the hash function. Okay, let's leave this like so. What about to FPT and that would be equality here. The problem is, right, that it's not exactly in the format that we need on AB. Now we need the hash function, and unlike what I assumed, it's not in the real core library. So we'll have to implement it. And, we're in luck since, let's see, plug in the core is here, the old core. And it should be here, I think. Yeah, here we have the hash. F sharp, side tone. Hmm. When I'm reading these C++ examples, they are all using bit shifting and the XOR function to do hashing. And I myself am instead using multiplication. And I think shifting and XORing would be more efficient. Not sure what exactly should I do. Okay, so I have this. Let's just copy paste it for now. In fact, let's just copy paste all of it. Now we have the backend switch, so you probably won't really need separate functions for F sharp and Cython. This was made like half a decade ago. Mm, It would be more fair to just call this Python. Okay, let's and switch real. But what exactly? Okay, for let's call it F sharp. Two. Okay, this is Python. They did not copy paste the backend switch real. Backend switch real. Okay. Wait. It was this printing. Uh, so this is the cache for the primitive. I guess we can also do that. I mean, no, no, no. They should all be like integers, like default integers. No, but if you do that, it won't really work on. This is so. This is I can really. Okay, this is the seed. And this is the max half. We should. Let me just take a look at the quality. Am I missing something? These are the same as before. Symbol, layout, union, body, and join body, order. This just takes the type for 0, actionable. Wow, I'm impressed that it does have. I don't think I even have hashable. Oh, I do have. Oh, nice. Yeah, it's pretty much everything that I want is actually all the cases that I want are actually here. Takes care of the nominals. Wait, why is this if prototype has? Else if prototype has a. I mean, only the nominals can have prototypes, so this cannot possibly be a valid case. Maybe back then, maybe I intended to put in prototypes on types others other than nominals, but that never came to fruition. Okay, so what we could do is maybe do a conversion to an integer. Just see how this is defined here. We put in a type and the value. Okay, so this will just be a default integer. We also got to think about exactly what we want to do with C++, and it actually isn't maybe a bad idea to try to do this using h. Using just stud hash int and then stud hash int, and it's we can see how it's actually using them here. It creates this object and then uses it to hash a value. Yeah, we could be doing that as well. Instead of just having this h here, we could just inline the stud hash for a particular type and hash it that way. Okay. Mm, let's just write out stud hash. Um, I'm just going to use int here. Now we don't have to put in the types here explicitly. We just do And this seed is just a prime number. There, it can be like this. We won't need to convert it to an integer. And this should be in like stud cache. This type should be the type of X. Why is this happening? Literal variable. I mean, I'm kind of doing something similar here. I'm taking the, the type, then the type of an expression. Maybe like, no. This is a turnover macro. Oh my god, this happens when you forget how to actually write code in your own language. Oh, there. Let's just leave this like so. I'm going to figure out how exactly to get the type. Like maybe you can just do a type case and type case. Yeah, what exactly is this tag convert? So it's to convert the type of the union tag, which is typically 32, regardless of what the default is, into um, into the default integer. I mean, we can just do a convert, like convert int. Wait, but we don't actually know what the union tag. No, actually we do. I mean, the partial evaluator will know what the type of the input is. That's not a problem. This thing is this really the only way to actually? Suppose I did this and then put in 2. Here I have x. Is it really okay? The parsing works as would as one could expect in type case. I don't know. I give up. It doesn't matter too much. I guess I'm just mistaken about how the type parser works in Spiral. I guess we have to do this type case to get the type of X, and then we can then pass it into the macro. It's not really a big deal. Wait, first we have to actually construct the object, and then we have to pass the input to it. Yeah, I forgot about that. Okay, so yeah, this is how the hashing should be done in C++, most likely. Okay, not bad. Uh, I think instead of using this, we could make things faster by using backend switch and safe. Well, let's do that. Backend switch and safe, and the regular backend switch actually gets evaluated for every single case in the partial evaluator, regardless of the backend, and that's for like type coherency reasons, type soundness reasons. But if you use backend switch, it will just evaluate the particular case for the backend, and it won't be causing us trouble. So okay, so how is that used? Save backend switch. Now it takes in a record and then it just applies the particular node. Okay, with a unit type. Okay, so like this. We have a record. Do this. We need those for exclamation marks to use an inbuilt operation. And we also have to put on save at the start. Okay, nice. Okay, there could be potential bugs, but the only thing that I'm really concerned about is whether on the CUDA side we'll be able to use this stud hash. It's possible that we won't, but even if that's the case, then whatever. We only really need it on the host in order to use the unsafe. To use the unordered map, to use the dictionary, and we don't need anything else. Wait, so we still need to put the hash into the core library. So it takes in a key and then it spits out an integer. Okay. So let's see. Nothing base, not in real core, nothing game. Let's see. What do we even have this? Remote caching. Int. And now we can actually try using the hashing here. Here. It doesn't know. Let's just provide an annotation. And this is going. This function pointer is going to be fptr, and it's going to be what? Yeah, let's just copy this. No wait. This should be key. This should just be of key to int. It's not really. It doesn't take a pair of keys. This is just. If I put in. Yeah, it cannot infer it. I don't. Yeah, this isn't a nominal, but type level function, so it cannot infer it without the full annotation. So we have create dict. Okay, let's start creating it. Create dict, and put in 8 as a capacity. Let's try building this. Let's see what comes out. Function pointer method 2.0. No, it's trying to. Yeah, I think this is hashing. And this is most likely equality. Let's try compiling this. I want to see what happens. Did we get it right? It actually compiled and ran successfully. Suppose we create multiple dictionaries, like, let's say, with the same type, like this. And then we build it. We need to reuse the same function pointers. Oh, yeah, it does. These have the same type. Well, this is extremely convenient. Yeah, so in Spiral, if you can in Spiral, you have records, union types, and tuples, and you can use dictionary objects seamlessly with them. It's no problem at all. And the Spiral will automatically generate the hashing methods and the equality function for them. let's go even further. Since we have this, what we could do is put this in a separate module. Or Cuda, Cuda host. Maybe we have. Okay, so let's put it like here in core Cuda host. We have the dictionary module. Well, let's open for base. Now this test. Let's make globals. We're just going to call globals every time this is created. I mean, it would actually be better to just call it every time the type is printed, but that would be too much. Okay. Yes, what we have to do here, now that we have a way of creating the dictionary, is how do we put things in that dictionary? We have the dictionary, so we need some way of inserting the keys and then getting them. So there's no, actually, sorry, it's not pushback, but what then? Oh, so it's just setting the key and then. Okay, never mind. Let's ask Perplexity. C++, or what? Let's just put this into a search engine. Memory storage. Contains metal members functions const x. I'm surprised that this didn't have it before. So this is so it's stood hash key by default, stood equal to key. In fact, putting it directly into a template like this instead of passing in like a function pointer would probably be more efficient than what we are doing. I just don't have really a good way of turning a function into like a functor that matches this interface. Suppose I build this. Crap. This is okay. Caching this is fine. Tuple int bool long int crap. No, this isn't good. I was wrong. We need that. I need the two arguments to be 2.0, 2.0. Oh yeah, I don't know what I will use it. I just remember an existence of something like here. If we look in base, I think there should be args. Yeah, nominal arg x equals x. And you might be wondering, what's the point of this? Well, the point is, yeah, the point is exactly this. Now, in fact, we need to also put it on the hash. And I'm really surprised that the C++ compiler didn't raise an error over this. Let's try this. And what do we see now? Yeah. Yeah, this is just a little trick because if you just pass in the arbitrary types as they are, they'll get unpacked. So by wrapping them in a nominal, we get the actual behavior. Oh, yeah, the C++ compiler really is garbage. It doesn't do any type checking at all. We'd probably get an error when we actually tried running one of the functions, like that uses equality or hashing. And this behavior very much reminds me of old Spiral from 2018. They cannot do inference bottom up, and I don't like it very much. It's actually it makes it a lot harder to use the language. And unlike the old Spiral, even in the new Spiral, you have those bottom-up segments, the real segments. They work the same way, but at least in Spiral, everything you aren't really restricted to having to put these types everywhere. So C++ kind of has the worst of both worlds. Mm. It's going to be creative. We could just pass the hash and the equality directly through the template. Suppose we try doing this, then we'll leave it. Yeah, even this works. I mean, yeah, that cannot be possibly be the case. Like, What the hell is C++? Alright, we're going to check this again. Let's just focus on implementing all the operations. Where key equal insert. Okay, so what is in place? I don't know, dislike how I do dislike the move semantics in C++. This is so complex and for basically zero productivity gain. Like, it's super easy to mess up. There's barely to point to it. What the hell is all this? Or a tuple then. Mm, yeah, instead of just adding, yeah, the set can just be done using a setter. And what about okay, let's insert. Can we bother to read all of this? And if it does, okay, so what's the difference between insert and place? Take a look at all this. This is so much functionality. It's pretty much inviting mistakes to creep in. Who is going to keep all of this in mind whenever they're using C++? You cannot. Okay, let's ask Perplexity. What's the difference? What's the difference between insert and place? C++ unordered map. Of course, you provide a full constructor key value pair. Wait. So this argument is not not the stood string, but the argument to construct a string. Both return a pair, one inter return a bool indicating the instruction success. Then we get okay, this is bad. This is also bad. I don't want exceptions being thrown. No, default constructed value. Not happy with either. X. Would it? Okay, let's implement this. Find let's just call this index maybe, or maybe just get, and we return an optional value. So what do we do here? Let's do this auto it. And with do. We just want to get rid of this type error. In fact, we can just return none for now. And this is of type auto it. Let's just put in a variable. And this is map find key. Yeah. So we also need, besides the dictionary, we need a key. Key. And this should be the dictionary. The find key returns an iterator. Then we have to do a check if Then what? The reason why I have two exclamation marks here is not just single one, because this is a macro, and a single exclamation mark would splice in a variable. So by putting two exclamation marks, it's the same thing like as escaping it. Okay, so if it's past the end of the array, then just return none. Wait, sorry, this is if it's not at the end of the array. Otherwise, we need it second. We need to return this. Some. Yeah, that's basically it. And now we can get the values from a dictionary. And we can get rid of this. Set. Let's also set the dictionary to a particular value. Okay, this is going to be a unit type. Value. This is very simple. We just have to do d and then g equals value. Okay, now we can try setting it to something. Let me simplify this a bit. Okay, let's do set. Let's do the one true SDF. True false. And let's do console write ln. Then I'm going to do index d one true. Wait, crap. The console write line is in a subsequent. Whatever. We can just put in dictem here. Who cares? Oh wait, this isn't index, but it's just get. And this two false. Let's just get rid of this. The directory. Oh, not bad. So let's see whether anything happens. Now we actually have the union types in a program, and it's printing them. Let's see whether this works. some ASDF, and this is none. Perfect, exactly what we'd expect. Um, Let me. Hello, world. Not bad at all. I mean, we have the get and the set. We probably also, at the very least, want the contains function, like know, on contains bool. And then let's see, how do we use and yeah, it returns a boolean. Okay, this is very simple. Contains yeah. Let's test some of that. I might then just do build file and then it should be on the actual file. None, true, false. Yeah. So the contains does work. Oh, okay. Are we missing anything else? I mean, we probably do want what? Like, I mean, why would we want to swap the contents? I mean, okay, we want clear. We want to also remove the element. But this, where is, okay, here's clear. 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 Raise. Wait, it's. Okay, so it does have an iterator. What's this size type? The number of elements removed. Oh, I see. So it just returns whether the element has been removed. Okay, okay. Is okay. Okay. Right. Um, Raise key book. And then this has to be a raise. And this has to be whether it's one. And that will, I think, convert it to a boolean. In fact, no, we don't even need to make a check. We can just say this is a boolean, whatever, and it will still work. Like one is true and zero is false. And maybe we could do static cast bool. I think this is how static casts work in C++. C++. Oh, oops, that's three pluses. Static cast, compile time conversion. This is good enough. Okay, let me do so right Ellen. We're just going to do it, right? We're just going to remove this element, erase, removing. This is going to be contains. Yeah, it removes it, and then it says when it tests whether the element whether the key exists in a dictionary again, then it prints out false. That's great. Okay, so yeah, I think this takes care of dictionaries. Now that we have this, we can do pretty much anything we want. Um, the only thing that I'm wondering, like, let's do a little bit of testing. Like, do we even need to pass in the function pointers? Oh yeah, it doesn't like them. Hmm. I wish I could just somehow pass in a constant expression. Mm. Who cares? It doesn't matter. Like, okay, so maybe there will be some indirection because it's going through function pointers to do the comparisons, and it will have to store them in the data structure. So yeah, that's not good. But at the same time, it's not really a big deal since we're just prototyping counterfactual regrets. Like this is supposed to be a super optimized implementation. I have to admit, I really am proud that this went so smoothly. Like everything that we need to actually interact with C++ in Spiral was already there. It's true that I had to add the new layout types to the language in order to maybe make some of the functionality a bit smoother, but otherwise it works very, very well. Um, what do we do next? We have the map, we have the layout types. Let's go with this. In fact, implemented C++, implemented a module for C++ and ordered in the extended for library. Uh, provides an interface to the C++. In fact, we should probably just create a separate module for the Soros or random number generator. Let's see. We go, for example, maybe here, draw cards. Find and set bits. Yeah, where did we even put the Soshiro? Okay, let me move all of that maybe there. Rather not. Actually, let's just move everything here. We'll erase it from here. And this is just supposed to be the game. And we're probably going to use some of this for non-limit hold'em. Wait, this is drawing directly from a deck. And what is the deck? U32. Book count, sample max must bit. This should probably be moved then. Cuda. Oh, this is a better link. Finds the position. Position is the turn is the offset. But unlike in something like Python, you don't actually see the names of the arguments in spiral. So how about we do this instead? Mask base offset. Mask base and offset. And yeah, now everything is pretty much broken, but whatever. We can just do mask base equals 0. Offset is this thing here. No problem at all. Wait, what the hell? Yeah, I thought I copy pasted it somewhere else. It seems I didn't. I want to move this where exactly? Okay, nothing here. Uh, Maybe in Xoshiro. Uh, nothing random. Understand? Let's just do sampling here. Uh, Open core base. Various functions to make dealing with dex with sampling bits from an integer easier are used to sample files from a deck. Popular games. And yeah, this is what Cuda. Well, I wish I could just move this into sampling. Sample mask a bit. Yeah, this shouldn't be here anymore. Pick discrete, sample discrete. I mean, if we get rid of it from here right now, it's going to break pretty much on the other modules to the get move. We're just going to leave it to do and be happy with it for now. Later, I'm going to just get rid of all the, you know, all the previous poker games and the machine learning library. It simply isn't very useful anymore. And this is just going to be for maybe sampling from the using the using the Philox random number generators and the other Cuda random number generators. Uh, 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 mm, 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 mm. So much stuff here. Okay, never mind that. So I'm going to open sampling. Do this. Open sampling. Yeah, let's do this. Now this is specific to the Lilac game, and we did manage to factor it out a little, so it's a bit better. But now we have collisions between the random module and the sampling module. It cannot be helped for now. Let's leave it as it is. Later we'll going to clean that up. What matters right now? Move some of the functionality into the sampling module. maybe I'll even, I'm kind of considering ending the video here, and then we can continue this in the next one after I've thought what exactly we need to do here. I think what we have the most important thing, which are the stack refs type, and we have the access to the C++ dictionaries. So we have everything we need to actually implement the counterfactual regret algorithm for the LIDAC game. Let's pause here and we'll continue on next time. See you soon.